Welcome everyone, and thank you so much for joining us for our digital Q&A session this afternoon with Kody Cook. Before we begin, I'd first like to acknowledge that I'm speaking to you from the traditional lands of the Kaurna people, and I'd like to recognise both their connection to the land, waters and sky, but also just the connection that Aboriginal and Torres Strait Island people from all across Australia have to the land, water and skies. And I'd like to pay my respects to the elders, past and present, and extend that respect to all Aboriginal and Torres Strait Island peoples who are joining today. My name is Hannah, and I'm one of the space communicators here at the Australian Space Discovery Centre in Adelaide. And today I'm assisted behind the scenes with Nate. If you have any questions at all throughout our chat today, please submit them in the Q&A at the top of your screen, or if you're in a classroom, just ask one of your teachers to do that for you. And if I have time, then I can pass them along to Kody to answer them. One last little bit of housekeeping. Our session will be wrapping up at about 2:45 Australian Central Standard Time. But definitely, if you have any more questions or if you happen to be in Adelaide, come past the Discovery Centre. Otherwise, contact us via our website just to answer some more questions. So, like I said, today our space guest is Kody Cook. And Kody is joining us. Where actually are you joining us from today, Kody?
Coming from Helens Vale at the Gold Coast, so just south of Brisbane.
Nice, awesome. And just sort of tell us a little bit about yourself and what you do, because I mean, you can see in the background you're at Gilmore Space, but that doesn't tell us a huge amount.
Yeah, not a problem. I'm one of the engineers who I regard myself as born rather than made. From a young age, I was pulling things apart, setting the house on fire multiple times, you know, building bits and pieces from parts that I'd bought from the dump shop and screwing them together. So there was a moment, I think I must have been about, 8 to 10 years old, and it was the realization of my parents came that was, oh dear, we've had an engineer, and I've had to send them my condolences ever since. I was pretty lucky that I was so into, understanding how things work. I really enjoyed mathematics. I really enjoyed and understood things which were logical and building and inventing things. And was super fortunate that there was a mechatronics engineering degree offered by the University of Queensland. And I was just like, cool, multidisciplinary engineering. I just want to try and learn as much as I can. Hardware, software, electrical, RF, thermal, doesn't matter. I want to learn it all. And so I went and did my bachelor's of mechatronic engineering. Was a bit of a glutton for punishment, so I took around for the master's degree as well. And during that time, I did as most poor uni students did, and I went straight out and joined the mining industry. So from that point on, I sort of saw my career path as being emerging out of the ground and heading towards space. So I did that for a little bit, and I worked on some pretty interesting systems in the mining industry with research and development. And then soon after that, I went and got involved in aerospace. So I joined Boeing in the early days on air battle management, and later the Loyal Wingman program in its very early days. And I cut my teeth on some really exciting programs there. Around that time, I started to get awakened to systems engineering and to more process-based engineering efforts, formal systems engineering approaches and things like that. Around that same time as well, we had the space agency was kicking off, and space, thanks to SpaceX and Rocket Lab and a lot of these new space companies, space was starting to be in our face. And here I was, had a bit of time up my sleeve, so I went back to uni and studied space engineering with the hope that I could head down that path. About halfway through that master's program, I got picked up by Gilmour Space Technologies. So I spent the next couple of years taking their initial satellite capability, their ground segment, and we essentially rebuilt the whole thing from the ground up. So that was a super exciting experience and a really validating engineering exercise. I'd learnt all this stuff, but I hadn't had a chance to sort of follow the design process all the way from start to finish before that. And just before I left Fleet Space, we managed to launch the Centauri 3 and 4 satellites, which was super exciting. We managed to develop a new version of the hardware, the software. The early days of the exosphere was done then, which was really cool. And then I wanted to head back home to Brisbane. So I was a Brisbane boy, born and bred, more or less. And I was enjoying Adelaide, but I wanted to come back home to the warmer weather. And so I did a little bit of work from Brisbane with the Australian Space Agency. And I spent a couple of months there working on some contract work for the Access to Space related roadmap. And enjoyed that as well. And it was really good to see the other side, to see how our regulator and how the government agencies work in supporting our space industry. And since that point, I then joined Gilmore Space, originally as a launch vehicle engineer, which is probably the most broad title anyone could be given. But I think it describes my role in the early days there quite well. I started off and my job was to ensure that all of the bits of the rocket got plugged together correctly and then was verified. So go through testing and inspections and whatnot. Had to make sure it was all plugging together right, that we had a good plan, and then preparing us for operations. So all the launch site preparations and whatnot. I did that for a number of months before I've now jumped into the role of heading up our software, electrical, GNC and avionics department. So quite a mouthful. That my role is to work on pretty much anything that has anything to do with electrons. It falls within the department that I'm heading up, and that's me now.
That's awesome. That's a really long and just very interesting journey towards where you are now. Just goes to show that, just because you started somewhere that wasn't space, it does not mean that you are going, you can't move into the space industry if that's not something, if that's something you want to do, which we might talk about a little bit further. But first I want to talk, so you are the head of software, electrical, GNC, avionics. That's a lot of stuff. What does your day look like? You've got all these things. What does the day in the life of Kody Cook at Gilmore look like?
Honestly, a lot of it is putting out fires. So my job is to make sure that everyone else is able to do theirs. So in this department, it is vastly complex in that we have a whole swath of different engineers. We've got systems engineers, RF engineers, we've got mechatronics engineers, software engineers, algorithm, GNC engineers. So we have this vast array of talent, and we have an enormous swath of activities. We're developing custom-made avionics boxes. We're writing custom flight software to be deployed on those boxes. Where for the stuff that we don't want to build in-house, we've got to select the right equipment for our telemetry systems and whatnot. Make sure that we're buying all of the right external gear. We have to stitch all of that stuff together. We have to qualify and validate that it's going to work on the vehicle. And then we have to be able to simulate and fly those missions over and over again to ensure that our vehicle is performing in a safe way, that we can verify as much of the vehicle as possible before we get to launch day. So there is a lot of scope inside that software, electrical, GNC, and avionics department, the structure there. And a lot of my day, a lot of my job is just ensuring that we've got everyone in the right position, doing the right jobs, and that all of the major issues and major risks are being burned down so that we're maximizing our probability of success when we get to the launch pad. And I know that sounds a bit abstract. I used to be very much down in the weeds. Nowadays, I'm sort of sitting up at the high level and just putting out fires as I go a little bit at the moment.
Yeah, that sounds logistically almost a nightmare. But so I suppose you'd have to be very good at management and just being able to keep an eye on every little bit and understanding how it all fits together. How did you find going from a very like you said, down in with all on the very technical stuff, and then moving towards more of the manager sort of roles as especially as someone who was trained as an engineer? I'm sure there's in your experience, you've had engineers who've gone into management roles that they don't have the skills. Like, what sort of personal skills and how do you need to survive in your job? And also, like, how did you learn them? If that,
really good question. We, to start with, not all engineers go on to be good managers, but a lot of really good managers in a technical discipline comes from an engineering background. And one of the things that I've realized is that I can sort of offer from my experience. You know, I was always like a drama kid, I guess you'd say. So I did a bit of the film and TV and arts back in school, and then got into some of the mathsy, physicsy, chemistry stuff. So I was a bit in both worlds there. But one of the things that I think I bring to engineering is I guess my extroverted nature to try and ensure that the technical aspects, the deeply technical aspects to what we do are communicated well. Because when it comes to leading and managing a team, the biggest thing that has stopped us from being able to progress, most of our challenges, and don't get me wrong, we have our technical challenges that we work through. There's a lot of problem solving going on here on a day-to-day basis. But a lot of them are just making sure that the entire team's aligned. Because I remember one of my mentors telling me back a while ago, is like, you can think of everyone as like as fish all swimming in the same direction. When we're all aligned, like a school of fish is very organized, very productive. If one fish starts swimming in the opposite direction, it diverts the rest of the school. It causes chaos. So that lesson I've sort of taken on, and I've put a huge amount of emphasis into ensuring that before we tackle something big, like a big technical challenge, we've got to make sure that we're aligned in that challenge being an appropriate priority, and that our approach to achieving that outcome has been defined in a way that everyone agrees with it. So it's really a people thing. As for where I've learnt the skill, I would say in the past, personally, I haven't always done a good job of being a people manager. I'm very outcomes focused. You know, I like to see things working. I like to see us moving in the direction of providing outcomes. And I've made a lot of mistakes from a leadership point of view. So I'm very fortunate that I guess early in my career, I was given some leadership opportunities, and I've leveraged those to be able to now try and provide really positive outcomes, both for the team and for the business.
I love how many ex-drama kids there are in the space industry. There's quite a few, actually. You don't have to look very hard to find it. I would say, sort of going on from this, like, what sparked your interest in space? Like, why space? Where did this come from? Yeah, I mean, obviously, other than it being exciting and cool. But we're
about to get deeply.
Yeah.
Yeah.
Let's do it.
All right. I'm going to get philosophical here a little bit. I liken space in the modern times to the early settlement of and colonization and trade and whatnot. We look at what projects like the Transcontinental Railway did for the US, and we see what happens when there's something which is economically viable sort of over there, and we see that the expansion of mankind going out into the universe is something which can be really fruitful for humanity. It provides us with an opportunity to go out and to explore. And human beings, I believe, are fundamentally explorers. Like, we want to go out there and we want to get out into the universe, both from a curiosity point of view and also from a tangible survivability point of view. You know, we've got a shelf life on our solar system. So at some point, we've got to start heading out there, and we're getting to a unique point in history where we have the technology and the ability and the motivation to go do that. We can imagine what the state of the world would be like if we never had ships or we never had trade. You know, we wouldn't have spread out as much as we have. And I like to be an optimist. I don't like to think that humans are going to go out and ruin the entire universe if we go and spread out beyond Earth. But I see it as the next step in our process, you know, the next step in human exploration. And I think that a world I'm going to be quoting some other people here, but a world or a universe where we're a multi-planetary species is far more exciting to one which we're confined to a single planet.
I love that. It's almost like, so it feels very science fiction at this point, but who knows, like it could be science fact very soon, especially if Gilmore gets that way. I suppose like you're talking about the possible like opportunities of going to space and exploring the universe. And so I suppose like what do you see as some of the biggest challenges for Australia and honestly just humanity in space? Like how do you think we can overcome these?
Oh, that's a good question. That's a really good question. What are the opportunities? So that we have developed a lot of our technology that we have today around the resource constraints that we have here on Earth. That the price of titanium is what it is because it's so hard to manufacture, sure, but because it's a mineral that's hard to get and hard to work with. We may have an abundance of these rare materials out there, and who knows what's technologically possible if we have access to these abundant raw materials. There will be limits which have been a constraint based on the availability of material, and phenomenal opportunities. Some phenomenal opportunities. The challenges is a big one as well. So we have, I guess, space itself, and I'm gonna say something which has been said a million times over, that space is hard. And I'll go one step further and say launch vehicles and deep space exploration is even harder than some of the initial stepping stones towards space. So you can develop satellite payloads, and you can develop services that support space, like ground services and in orbit satellite services and that sort of thing. But to develop from the ground up a clean sheet launch vehicle, or to develop a clean sheet satellite or a space plane, to build this stuff is so technically challenging. It's so multidisciplinary, and you are literally on the cutting edge of possibility from a core physics point of view. So that is a challenge that everyone in the space industry faces. Earth's gravity well is quite deep and quite hard to get out of. So if the Earth was something like, I think it's 30% heavier than it was, there's a question about whether space travel would even be possible. And I'm pulling numbers out of my butt here, so bear with me there. In terms of Australia, though, we have everything that we need to be able to have a flourishing space industry here. We've got smart people, we've got a good regulator, we've got a good technology base. Honestly, a lot of it's just come down to Australians not really having or taking on that risk of doing these big, ambitious projects, at least up until the last 10 years, where we start to see these space startups starting to kick off and go, to challenge the status quo, to start trying to be involved in a competitive international market. So we're just getting there. We started pretty late compared to other nations of similar GDP, size, economics. We've started late, but I don't believe that we won't be able to catch up to the international markets.
I suppose like going on from that, like you've talked about how, we've seen a lot of change in the last maybe 5 years here in Australia. You can attest, being in the space industry for most of that, you've seen that change. How much change do you reckon there's going to be in the next 5 to 10 years in Australia? Like, it's almost like unimaginable for me how much it could change. I would love to know what your thoughts are on where we might flourish and sort of where space technology might evolve to in the next 5 to 10 years.
I think that the first factor of how much this will flourish in the future is firstly around funding. There aren't too many new space companies, which are cash flow positive in terms of being able to completely self-sustain their revenue. So we need that. There's two primary sources of funding for big space projects, and the first is VC funding, and the second is government funding. So a big determining factor is going to be whether there is capital which is injected into the space industry itself. In both cases, what drives these investors, government or private, to put money into the space industry is the belief, like them truly believing that there is going to be success out of their investment. And to demonstrate that, to prove that, we need Australian companies to be launching or to be deploying satellites or to be successfully providing these services. So we as a nation, Australia, we got to get some runs on the board. We did some phenomenal stuff back in the 70s, but that sort of tapered off, and we've had a bunch of international big defense primes and aerospace primes move into Australia, and they've provided some capability, but that's not, for the most part, sovereign Australian technology. We need Australian technology to be going out into space. And when people start to see that, if Gilmour is the company that does that delivers a vehicle into orbit and takes the Australian supply chain with it, we have the ability just to say, yes, we can. This is Australia. This is Australian technology. And, it may be, the space machines, it may be the fleets, it may be the Innovors, but as an industry, as an Australian sovereign industry, we need to be demonstrating that these technologies, that these missions, these goals aren't out of reach for us. So it's going to need some wins from the space industry. We've got to step up. We got to prove that we're worth what we say we can do, and I truly believe we do, and we can deliver on what we've set out to do. And then it'll be up to the government agencies and private investors to then fuel the fire that we start.
Yeah, well, I suppose that leads me on to you've got a launch coming up. What's left to do for that? So I think maybe towards the end of the year, that's very soon.
Yeah.
Very, very exciting.
Yes.
What's left to do for that? There's a lot, I'm imagining.
So if anyone's been following along for the Gilmour media, so on LinkedIn or Instagram or Facebook, you would have seen that we completed the outer mold line at the end of last year. That was sort of our big Christmas reveal. So that is all of our major structural elements have been constructed and put together. And right now, if you went into our factory, you would see that we're screwing on the avionics boxes. We're laying out all of those harnesses. We're installing the rocket engines into those structures, as we speak right now. We are most of the way through integrating our first stage, having all the parts built, having it all assembled. In the next 3 months, we're going to have the rest of that stage constructed. We're going to chuck it onto a truck, and we're going to ship that up to Bowen, up to our launch pad. And then we're going to do our initial launch readiness testing up there. So that's a big part. The integration's challenging. It really is. And we have had many challenges and very startup style problem solving to work through the technical and logistical challenges that we've faced. But that's really it. We've got all the bits and pieces, everything's here. We are just absolutely hardcore into stitching everything together at the moment and making sure that everything works as expected. So you'll see in the next 3 to 4 months, you'll see our stages come together. We'll ship those up to Bowen. We'll assemble the whole rocket up in Bowen. We'll do a bunch of testing up there. We have to commission our ground segment. So make sure that our big RF dish can talk to the rocket. We have to do all of that testing. We've got a whole launch pad there, which we've built from the ground up, which is pretty awesome. And we've got to get all that working. We've got to plug the rocket into the ground system. We'll get the rocket vertical. We'll go through our dry and wet dress rehearsals. And then we're ready to launch. We'll be hitting T0.
That's sick. That's so exciting. And you're going to be, probably not live streaming, but you're going to at least get some videos or something. Get people excited about it, being able to show off the hopeful success.
I won't make any promises, but a live stream isn't off the cards. So we may see we may keep the public along for the journey as we're doing that testing and in the lead up to launch. And we've been chatting with some of the space commentator focals as well. So we've had a little bit of a chat with Marcus House and that kind of thing as well. And he's done a few updates on us over the time. So I don't know, maybe we get him a bit involved at some point. We'll see.
That'd be good. That'd be awesome. I know we'll definitely be keeping an eye out. If you live stream it, definitely want to show it off here and get people excited all across Australia for Australia launching rockets. More rockets.
It'll be Australia's first domestic, sovereign developed domestic orbital launch vehicle, and it'll be our first launch attempt from an Australian owned and built launch site. And we're going to be taking, when we go to orbit, we're taking 300 companies in our supply chain with us. They will have space qualified hardware the moment that our rocket gets into orbit. So we really do want to bring the entire nation with us when we go to space.
That's just so exciting. It's great to see how, especially in Australia, how all of the companies, they're all very small, working together for this just combined goal of growing the industry and being able to show to the world now we can do it. We're good at this. Sorry, you go.
I was just going to say, we've got there are so many little niche pockets in Australia of awesome capability as well. I'd say we do have to step up our game in terms of manufacturing a bit. I think relative to the other nations, we've got a little bit of a deficit there, but I know the government's putting a lot of emphasis on manufacturing looking forward. But I mean, we've got companies who are helping us wind carbon fiber around our COPVs, our pressure vessels, and our rocket engines. These are all, a lot of these are capabilities which are Australian born and bred. So that it really is exciting. That's one of my favorite parts of working for this company and working on this mission is this is an inherently and completely Australian mission. And that butters my bread.
It's so cool. I suppose a little bit of a different question, but this came from one of it was a Q&A question. I suppose, how does competition affect the development of space tech, especially with your rockets? And does Australia have room for such competition in developing launch vehicles?
Yeah, so I guess there's two questions. It's can Australia compete with the international market? And can there be competition inside of Australia? In terms of can Australia compete with the rest of the world? Yes, absolutely we can. And I look at the launch manifests coming up for a lot of our competitors. We've got Virgin, well, not Virgin anymore, unfortunately, but we've got Astra, Able Space, we've got Firefly, I already mentioned Astra, Rocket Lab, SpaceX. There are a lot of people out there launching, but at the same time, the launch manifests are filled up for 2 to 3 years in the future. If you have a payload, if you have a satellite right now and you want to launch it, you're waiting a fair amount of time before you've got availability open up on primary payload or rideshare. So there is absolute space services, communications, defense applications. There is such a market out there for putting stuff into orbit, and there are not enough companies and launch vehicles to be able to service that need on an international level. Internally to Australia, we have the space agency that's been spun up. We've got the Trailblazer grant, which has gone out. There's been an indication from government that they want to feed the Australian space industry. From a launch point of view, I don't know if having multiple launch providers at this point in time is a necessity. It's a good thing to have a bit of friendly competition to rising tide lifts both sides kind of thing. But I definitely believe that from a space services point of view, I think it makes a lot of sense to have a lot of internal competition as well, because we have a lot of capabilities that we want from Australia, and we want people to be able to compete, to be able to service those government bids and whatnot. So I think some competition's healthy. At the end of the day, it'll be those companies who can really demonstrate, can really prove themselves, who are still around in 10, 15 years' time. But I just think we're going to keep putting more and more and more mass into orbit, and then beyond orbit out to other planets. So I think the market's just getting started.
Definitely. So you did a short stint at the Australian Space Agency looking at regulation. How do you feel that your experience in being around like the development of regulation related to space technology has helped you be a better space engineer, like being able to understand it from, not only understand it from like a business point of view and a technical point of view, but also the like regulation around what you're doing, especially with like launch vehicles where it is a heavily regulated activity for obvious reasons. Do you feel that maybe that small stint that you had has helped you be a better engineer, or just it was fun for a bit, cool experience?
Honestly, I'd never worked in government before. And to be fair, I didn't work in the regulations team at the agency. I was working on the technology roadmap side. So it's having a look at all of the companies out in industry and trying to come up with a plan that would support as much of industry as possible. But I still did get a deep appreciation for the regulatory aspect. And I've worked on a lot of development programs in the past when I was at Boeing and when I was at Fleet and whatnot. And regulations does have a major ability to be able to halt or slow down development. And one thing that I've been quite appreciative of comparing CASA, comparing the Space Agency, ACMA to the US counterparts is we've got a regulator who is understanding of the environment that industry is operating with, in terms of, you know, our maturity as a newly flourishing space agency, and being able to not have a purely, you know, throw down a 500-page book on here's all the rules, and then all of a sudden no space companies anywhere can get off the ground, especially when we've got so many startups in the mix. So we've got our Launch and Returns Act, and the Launch and Returns rules is the primary regulations here in Australia, and there will be adjustments as we start to have more and more launches taking off. But in this point in time, I've just been really appreciative. Our conversation with the regulators has been very constructive. You know, we brought them in early, and as they have with a lot of their launch vehicle or launch services providers. And I think without having a regulator which is trying to support a flourishing industry, a lot of this stuff wouldn't, excuse the pun, but wouldn't get off the ground.
Just wouldn't fly. Sorry, I've distracted myself with brain pun. But as just reminding all of the attendees, we've got about 10 minutes left. Also, it's kind of a reminder for myself. So if you've got any questions, please do post them. We've had some great ones so far. But until we get some more questions coming in, maybe pivoting a bit more towards, do you have any advice for anyone who is wanting a space career, especially maybe ones like yourself who, you know, like they didn't start in the space industry and they're potentially thinking about going back to university or going back to school? That's like a big risk. So do you have any sort of just advice for people like that?
Yeah, it is tough, like engineering things in the mining industry, ground aerospace systems, you know, airborne aerospace systems, compared to space platforms. Space is hard, you know, it is a real challenge. If you can build something that can withstand the radiation environment of space, the rapid cold to rapid hot nature of going around the Earth in orbit, to withstand the vacuum of space, like this this is one of the most extreme environments that we've tried to build platforms to be able to survive. So my big disclaimer is that it's a challenge. So if you want to chase this industry, know that it's hard work. But my disclaimer to that is it is the most fulfilling thing from a career standpoint that I've ever been involved in terms of getting into the space industry. You know, I still remember the moment that I was standing on the ground with a little communications node, and our satellite did the first pass overhead, and we saw the data coming down from the satellite, and I was like, we started off with somehow getting electricity and putting electricity into a rock as the start of like building silicon semiconductors, and then somehow through some invisible means of communication, I can get data from the other side of the world in a matter of minutes. Like it's when you take a step back and realize what you're doing, like these are phenomenal activities to be involved in. Like it is just so cool. We have with a lot of these space companies starting up as well, for those who haven't come from a strictly really hardcore aerospace engineering background, we're pretty open to exploring your experience in contrast to the roles that are being offered. So even if you don't necessarily meet 100% of the criteria in a job application in these new space industries, it's still worth throwing your hat into the ring. And if you've got the ability to go back and to upskill, that'll definitely help your chances as well. But I'm definitely a testament. I started off in the mining industry, and now I'm here building rockets with Gilmour. So there is absolutely so much opportunity taking off in Australia at the moment. And if you are interested, it is a challenge. It is extremely fulfilling, but I encourage you to throw your hat into the ring, give it a go.
Yeah, I love how you mentioned that you don't, just because you don't think that your skills relate to the space industry, it doesn't mean that they actually don't. Like, we get people coming through the center like weekly, multiple times a week, being like, oh yeah, no, I'm just interested in it. I don't actually have anything to do with space. And then they will probe them a bit more, and they're like, oh yeah, I'm in like cybersecurity, or I'm in medicine, or I'm an artist.
Perfect for space.
Yeah. Exactly.
Perfect for space. Yeah, all of those things, right?
We all of them.
We in South Australia, there's a really good presence in terms of the bioastronautics. So how do human beings, how do plants, like how does all that stuff work in space? We've got some incredibly good space lawyers for the legal aspects to sharing the space environment with other nations. Like geopolitically, that's really fascinating. From a legal standpoint, it's really fascinating. Obviously, I've got the biased opinion of coming from a heavily engineering background, but space itself is for everyone. There is opportunity, and as we start to have a commercial space station, as we start to put human beings permanently on the moon in some point in the future, with the Artemis missions, with the work that's going on to try and get man to step foot on Mars, that's we've got some really exciting events coming up. And there is so many parts to that journey outside of engineering. So definitely I'll watch this space kind of one for the next 10 years.
Absolutely. So we've got about 5 more minutes left. We've got another question that's just come in from Sid, who's asking, like, as someone who's been in multiple, like, different roles in different parts of the Australian space sector, what would you say have been like the common themes, and what would you change? It's a tough one to probably almost end on. But yeah.
It's a really good question. There's I guess the big delineation, I believe, has been something which has been contextualized as old space and new space, right? Those when you're launching a geostationary satellite, which costs $1 billion, and you're developing that over 10 years, it's a very different approach to engineering. You have to try and you follow what's called the systems engineering V. So you do all of that upfront high level engineering, and then you decompose it as you go down. You break the system apart, and then you design each granular little bit, and then you pile it back in together. So if you're working in that sort of traditional aerospace, traditional systems engineering setting, it's quite different to the new space setting, which is really about trying to take an agile approach, still agile from the software world, and implement that in hardware. And the theory there is that, like, if you want to build a car, you don't design the entire car and then slowly put it together. You build a skateboard, then a scooter, then a motorbike, then you build an SUV. You eventually get to your SUV, and you take a very iterative approach to determining what your requirements are as you go. So that's one of the big changes between, I guess, the two different types of space development that's typically done. Out of both of those, I found taking an iterative approach, getting your hands dirty, test early, like build as quickly as possible, learn those requirements by testing as soon as possible. I found that to be more of a rewarding approach to engineering. So that's the thing that I'd like to see in the world sort of take off more, is for companies, for engineers to start to get more involved in an agile or concurrent engineering approach, so that we can start to see more cool things spun out of Australia.
Yes, I think it would be really cool to start getting things moving quickly, and well, they're moving quickly already. Space does that, but just even quicker as we start to have new rockets. Just get things moving, get it all exciting. I suppose that'll happen after your launch as well. Got a couple more minutes left, and I suppose, like, just to finish up, we get lots and lots of teenagers coming through the Space Discovery Centre, and I'm sure you'd get them coming to any sort of outreach that Gilmour has. They're interested in space, but as teenagers are, a bit lost, bit unsure. What would you have told? What would you tell your younger self, your teenage self, that potentially would have helped a young Kody through that time of finishing up high school and moving towards either university or TAFE or whatever's next?
I honestly, it's, for myself, I'd say it's a bit of a stop and smell the flowers kind of thing. I've been so driven in the past 10 years just to try and be working on the exciting stuff, to get to working on the current project I'm working on. And I think it's sometimes, it's really good to have those goals, and you've got to run hard, you've got to work hard to accomplish things, be outcomes focused. But at the same time, you got to stop and smell the flowers. And every now and then, even working here, I'll have a hectic day where I've been pulling my hair out, and then I just like look around. I'm like, at the same time, yeah, today was a stressful day, but I am so thankful to be here. I'm going to look back and go, these are the golden years. You remember when we were out there, working till midnight, stitching together that simulation engine that we then ran on our hardware environment, and we saw that work for the first time. Like, yeah, they're really cool journeys, and we're so lucky to have such an awesome team, not just here at Gilmour, but in the wider space industry here in Australia. We've got a heck of a lot of really bright people, and I just feel so thankful to be a part of this journey that this company and this nation is going on as we venture out into space. And but don't forget to stop and smell the flowers.
I 100% agree. Some of the best things, when I look back, some of the hardest things at the time I was doing, probably looking back as some of the most exciting, most fun parts. I suppose, yeah, that's all the time we have for today. Thank you so much, Kody, for joining us and sharing your story. It's been absolutely fantastic. And also thank you so much to everyone who tuned in this afternoon and listened to our conversation, submitted questions. It's been absolutely great. Like I said at the beginning, if you want to learn more about space in Australia, or potentially even how to become a space expert yourself, where to go from to find your way in the space industry, definitely please, if you can, come and visit us at the Australian Space Discovery Centre, or again, check out our website. There's lots and lots of very cool and informative information on there. But again, thank you so much, and I hope you have a good rest of your day.
Thanks very much, everyone.